Scholars International for giving an opportunity to talk at the this online event on chemistry, drug discovery, and drug development. The topic that I'm talking here is basically targeting alpha amylase and alpha glycosidase. Basically, this is a theoretical experiment which has been conducted in our group, and through wherein we have implemented some virtual screening of chemical libraries to identify some potential anti-diabetic agents. As everyone is aware about, that diabetes is one of the major diseases that is prevailing across the globe, basically marked by an increased levels of blood glucose classified as hypoglycemia. The major causes of diabetes being insulin resistance, relative insulin insufficiency, and there is an increase in the endogenous glucose production as per the International Diabetics Federation records in 2019. Diabetes has reached alarming levels, and has the people that have been affected because of diabetes has crossed 500 million across the world. And it's just not a threat to individuals, but it is also affecting the socioeconomic status. Diabetes mellitus, which I'm in this case, which I'm talking about, it's a serious and it's a long-term medical condition which has been majorly impacting the lives, just not of the individual who's been having the disorder, but it also affects the families and the societies. The global diabetes prevalence indicate that in the year 2019, that is the 2 years gone by, there were around 463 million people being affected with diabetes, that working out to around 9.3%, and is expected to rise to 10.2%, which is uh, around 578 million by 2030, and around 700 million by 2045. It has been seen that the diabetes is found to prevail higher in the urban areas, with around 10.8% being the percentage, whereas in the rural areas it's around 7.2. Also, the high income countries show a percentage of around 10.4 of the population, whereas the low income shows around 4%. In a nutshell, we can say that every second person as of now is either living with diabetes, or is unaware, or is being exposed to the conditions. There are a variety of targets that have been exploited as of now, and some of which there are already medications available. This includes basically the tyrosine phosphatase, the dipeptidyl peptidase 4, G protein coupled receptors, the free fatty acids receptors, the PPR gamma, the alpha glycosidase, aldose reductase, glycogen phosphorase, and a couple to name more. The drugs that are available right now in market belongs to the categories of sulfonylureas, meglitinids, bigonides, diazolidine and alpha glycosidase inhibitors. As of now, there is a couple of molecules only existing that target the alpha glycosidases, that is acarbose. As of now, there are also DPP-4 inhibitors in the market, like saxagliptin, sitagliptin, and a couple of glucagon-like peptides, the GLP-1 peptides like the exatinib. Basically, type 2 diabetes, when there is a failure with regards to insulin in uncontrolled blood glucose levels, causing the blood glucose to shoot. The problem basically increases uh, after the food consumption, as absorption of food derived saccharides, the starches, rapidly elevate the blood sugar level. Alpha amylase is one of the targets, basically, which catalyzes the hydrolysis of starch. It's basically involved in the breakdown of the 1,4 linkages from to glucose and maltose, which makes it a major therapeutic target for the type 2 diabetes. Inhibitors of alpha amylase function basically by modulating the blood glucose level after a meal. Another enzyme is the alpha glucosidase, which is an important carbohydrate digestive enzyme, which is basically present on the brush border surface membrane of the intestinal cells. It also acts upon the 1,4 alpha bonds in contrast to the beta glucosidase, and breaks down the starch from the non-reducing terminal end, releasing the alpha glucose residues one at a time. It is proposed that alpha glucosidase is a glucose path plays an important role in the liver's metabolism response to the energy demands of the exercise. So the rationale here is basically to identify molecules which can target alpha amylase as well as alpha glucosidase simultaneously, thereby enhancing the efficacy of treatment and broaden the indications. This is the target, which is basically the alpha amylase bound to a known molecule, that is the a carbose, which is a groove pocket in to which it is the pocket is quite a large one. These are the interacting amino acids which hold the alpha carbose to the binding site. Another target, which is the alpha glycosidase, which to which also a carbose has bound, and you can see the interactions as in this point. So the basic goal of the study was to screen chemical databases libraries through virtual screening process, and filter them off using aid, that is absorption, distribution, metabolism, and excretion profiles, the predictions, and as well as the toxicity to fine line some molecules that can be taken into testing. So we started off with 7 million compounds, which we subjected to chemoinformatics analysis using softwares like Data Warrior. So we could weed out a lot of unwanted molecules based on molecular weight, the number of hydrogen bonding, the toxicity, teratogenicity, carcinogenicity, tumorogenicity. Based on these principles, we could weed out, so from 7 million compounds which were available, we could boil down to around 2.3 million compounds, which subsequently were subjected to preparation. As the compounds available were in SMILES format, we had to convert them, optimize them for the charge as well as the geometry, so as to make them optimal for the process of docking. Docking basically wherein we try to in the theoretical way, we try to find out the interaction between the protein and the inhibitor or the ligand through using algorithms. So the virtual screening workflow, what I've depicted on the screen here, basically was run at three levels. That is the high throughput, then the standard precision, and the extra precision. So uh, the ligands that were built using lick prep, around 2.3 molecules, were subjected to high throughput virtual screening, wherein it was quickly executed to retain around 10% of the top compounds, boiling down from 2.3 million to 234,000 compounds, which were subsequently docked, redocked basically to at a standard level precision, allowing enhanced sampling of the conformations while docking, reducing the or filtering out the compounds and giving us around 23,000 compounds. Subsequently, this 23,000 compounds were subjected to an extra precision docking, wherein parameters were made a bit stringent, and the cutoff lead for this was around -8 kilocalories per mole. This left us with 1,300 compounds approximately, while trying to dock them into the human pancreatic alpha amylase. So from 7 million compounds, we boiled down to around 1,300 odd compounds. Now, since we were trying to find out compounds which can dually inhibit the alpha amylase as well as the alpha glycosidase. The same molecules were also docked. That is around 1300 molecules, roughly 1400 compounds were basically docked again into the binding cavity of the alpha glycosidase, which is basically the N terminal known to have been active. So again, the cutoff was laid around -8 kilocalories per mole. Anything more than that was weeded out. So that left out with around 1200 compounds. These 1200 compounds were subsequently subjected to the online server, which is PKSEM filtration, so as to check in for absorption, distribution, metabolic excretion profiles, as well as the toxicity profiles. There was a double filter laid. One was at the starting using the data warrior, which helps us to reduce the compounds from 7 million to 2.3 million. This was another secondary filter applied that left us from 1200 compounds to just 97 of them. These 97 compounds were then subjected to free energy calculations, setting up the cutoff value to around 45 for alpha amylase. So from 97 compounds, we could identify 19 compounds. These 19 compounds then were sorted out into clusters, and 4 compounds were identified from the clusters as representatives, which could be further studied for stability, structural stability. So these are the results that we got after docking. So these were the 4 compounds, and their scores were -8 and less than that in terms of kilocalories per mole, whereas their free energy of calculations were around -45 to -46. They most of them showed the interactions, especially the salt bridge, as to be equivalent with that of a carbose, showing interactions with alpha amylase as well as alpha glycosidase. So many of these amino acids were same that were found in interaction, being hydrophobic or hydrogen bonds, or for that matter, salt bridge. So these are the interactions we could identify from the docking, which same has been tabulated as before. So these are some of the figures. So same molecules, as I said, were also docked into the alpha glycosidase binding site, and the results were also convincing. Interactions were also mapped to see whether the same interactions were observed that our carbose shows with alpha glycosidase. These are the images indicating the interactions and the interacting amino acids. So as per the flowchart, as per the process, as per the methodology we had done, as I said, we had done subjected this molecule to online PKSEM server where we could calculate the ADME toxicity profiles. So these are the physical chemical properties that turned out back from the server, indicating the molecule being in a acceptable range. The drug likeliness of these molecules were also accepted. The partition coefficients, the solubility was also acceptable. As far as the absorption parameters were concerned, all were predicted to have good absorption with no glycoprotein substrate, or for that matter, P-glycoprotein inhibitor. So they were devoid of any inhibitory activity towards the P-glycoprotein. Also, the ability of these molecules to cross the blood-brain barrier or the CNS was poor, indicating no CNS activity, and volume of distribution was acceptable range. The molecules were predicted to have 40 to 60% of binding ability to remain as unbound. So that indicating that would basically affect its circulating time. These molecules are also found to be non-inhibitors of the cytochrome P50, and they're also, it was devised to have the renal OCT substrate was absent, negative results. These molecules, when you're talking about toxicity, the predicted aims hepatotoxicity, toxicity, and skin sensitivity, as well as the HERG1 and 2 inhibitor. All these molecules were the results were satisfactory and acceptable. The molecules were then, as I said, were subjected to simulation. We had all these four molecules and complexed with the proteins, that is alpha amylase as well as alpha glycosidase, were subjected to molecular dynamic simulation. We had a runtime of around 100 nanoseconds per complex in a solvated system, maintaining the ionic concentration at an acceptable range of sodium chloride. So the results were accepted. This is basically the binding energy, indicating that the structure remains stable with a standard deviation of around plus or minus 3, with fluctuations within the accepted ranges. This is the binding interactions for alpha amylase, whereas this is the binding interactions for the alpha glycosidase. Empty results basically to assess the structural stability of the complex indicated three of the compounds to remain stable, except one compound was deviated in the lost its binding over a period of 25 nanoseconds. We are still into checking out trying to figure out what was the result as of why this interaction failed, whereas it was docked in a proper orientation. So the other three compounds were found to be stable. The RMSDs were between 1 and 3, which is an acceptable criteria, except for the one which violated. Even the atomic fluctuations of the molecules was within accepted range, and only the fluctuations of the protein in the terminals as well as the loop regions was found to be fluctuating in a 2 to 4 angstroms, whereas the rest of the protein remains stable. This is with regards to the binding free energies for the two proteins. So we can see that the interactions remain stable across the simulation time of 100 nanoseconds. These are the frames. So further on, we are looking at characterizing the biological activity using some enzyme-based activity assays, and further on chemical modifications to enhance the binding affinity as well as to improve upon the activity. So with that, I would like to thank and conclude my talk.
Yes.
Philip?
Thank you, Dr. Raghuvir. Is there any questions from audience?